All right, today we're going to talk about characteristics of linear functions. We use certain characteristics of linear functions to help us describe the relationship between variables. And in fact, it's really important that you learn, or you will become very aware of these characteristics. These characteristics really help us to define any function, or specifically linear functions as well. So they are slope or rate of change, domain, range, Y-intercept. Now the Y-intercept is simply the point where the Y crosses the X-axis. The X-intercept is the point where the line crosses, the Y-intercept is where it crosses the Y-axis. The X-intercept is where the point crosses the X-axis. So let's go here. So we're going to identify the slope, domain, range, and any intercepts for the functions. If I take a look at my function here, generally speaking, I like to identify where my points are integrals, or where my coordinates are, integers. So just to calculate my slope is my change of y over my change of x. Some people call this rise over run. Regardless, as I move between these 2 points, remember to move left to right, that my rise, it goes up 2 units, and my run goes over 2 units. So both my rise and my run are 2 units in the positive direction between these 2 points. Therefore, my slope is 1. Now, why did I choose these 2 points? I don't know, I just did. You could really choose them between any 2 integer coordinates, here and here, say. Or even here and here. You would say that your rise is 1, and your run is 1. 1 over 1 is 1. The domain for this linear function, now note how there's arrows at the end. So this means that the graph goes on forever towards the left and towards the right. So my domain really is x is element of the reals. My range. Now what is my range? My range is all permissible y values, and what we notice is my graph goes on forever up and forever down. And with the y direction, I'm going to go up and I'm going to go down without bound. So really what I would like to communicate to you, or you communicate to me, is that y can take on any value. So my range is y is element of the reals. My x-intercept. Where does this function cross the x-axis? Right there. And although we say it is a point, and you could list it as a point, the x-intercept I could write as -1. Or if you choose to write it as a point, you would say -1, 0. Now, what is it not? It is not x is equal to -1. X is equal to -1 actually describes a vertical line, so it cannot be this. So notation is very important in math. Now my y-intercept is right here, and that's going to be 1. So there I have my slope, domain, range, y-intercept, x-intercept. Now allow me to go on to the next example. B. I'm going to start off with 2 points, right there and right there. Why did I choose these specific points? I noticed that the coordinates were integers. That is, they crossed at the intersection of vertical and horizontal lines, like the grid marks. So my slope now is my change of y over my change of x, or you could view it as rise over run. Regardless, my change of y as I move left to right, my y value goes down 1 unit, and my x value increases in the positive direction by 1 unit. So my rise actually is -1. My run is 1. My slope, therefore, is going to be -1. So my slope is -1. My domain, very similar to the previous graph, x can take on any value because the graph continues going on towards the left direction and the right direction. So really what we're going to say is my domain is x is element of the reals. My range is y is element of the reals. And the reason for that is because my graph goes down forever and it also goes up forever. There's without bound. Doesn't stop at any one point. The x-intercept here is at this point. I can choose to write 3, or I could write 3, 0. My y-intercept is right there. My y-intercept, I would describe it as 3, or 0, 3. Your choice. All right. Hopefully, let's do something a little bit more. Oh, there it is. It's a little bit more challenging. Not much. I'm going to identify where my graph has points where the coordinates are integers, or at the corners of the grid. I'm going to choose this one and maybe this one right here. So recall that my slope is equal to my change of y over my change of x. Or sometimes we call this rise over run. Now I always start with the leftmost point right here and I go to the rightmost point. And you don't need to, but it's the way I do it just to avoid errors. As I move from the left point to the right point, I notice that my rise goes up by 1. My rise is +1. My run is going to be 3. So what I see is my slope is going to be 1/3. Now, it's not getting very exciting for domain, but it's really important that you understand. The graph continues to go on forever in the right direction and the left direction. So, therefore, my domain is x is element of the reals. X can be anything without bound. My range, very similarly, sorry, that set bracket was kind of not looking good. Forehead, nose, chin. My range is going to be y is element of the reals. And the reason for that is because my y coordinate, it can continue to go up as I go really far off the graph. That is, let me go. It'll go way up. And similarly, it goes way down on the other side, right? So my range is y is element of the reals. That is, y can be anything. My x-intercept here is going to be 3. My y-intercept is going to be -1. All right, maybe the last example. Hoping. I'm going to pick 2 points. And as I move from left to right, and I'm going to write slope. My slope is my rise over my run, if you want to view it that. And it's really nice to see on the graph. If you didn't have a graph, I would probably encourage you to use ya minus yb divided by xa minus xb. You would get the same notion. Anyways, keep in mind you also have a formula for slope. Sometimes you have to use that. My slope here, anyways, is going to be my rise. As I move from left to right, what I notice is that my rise actually is -1, I fall 1 unit, and I run 2 units. So my slope here is actually going to be -1/2. My domain is going to be x is element of the reals. My range is y element of the reals. My x-intercept, now it's interesting because my x-intercept helped me to use to find the slope. My x-intercept is this point, and it's -1. Or if you want, you could write it as -1 comma 0. My y-intercept, oh, pardon me, I made a mistake there, didn't I? My x-intercept is right here, right, where it crosses the x, and that's -2. Or I can say -2 comma 0. And my y-intercept is the lower one down there, and this occurs at point 0, -1. Or you could probably, I should keep this consistent, -1 or 0 comma -1. And there we have it. If you have any questions, please